Hello, my name's Ian. The problem we're doing today is number 15 from chapter 4, Physics C, period 2. A ball is tossed from an upper story window of a building. The ball is given an initial velocity of 8 meters per second at an angle of 20 degrees below the horizontal. Strikes the ground 3 seconds later. A, B, and C ask us how far did the ball land in the horizontal direction. B is in the vertical direction, and C is how long does it take to reach a point 10 meters below the level of launching. So how long does it take for it to fall 10 meters? So we draw our picture. This is my building. Here's the window. It's the horizontal. Starting at 20 degrees below the horizontal at 8 meters per second. So let's get our givens. We know acceleration is 9.8 meters per second squared, and acceleration for x direction is 0 meters per second squared. We know it's 3 seconds. And then for this, you can do 8 cosine 20 for that speed, and then you can do 8 sine 20. So for the y, it goes 8 sine 20. This is 8 cosine 20. When you solve those equal 2.74 meters per second squared. And then 7.52 meters per second. Okay, so solve for A. So we're going to do the x direction. So you have velocity, initial acceleration, time. So we're going to use the kinematic. X equals VIT plus half AT squared. So you're solving for x. Velocity initial is 8 cosine 20 or 7.52 meters per second at 3 seconds plus half. Oh wait, there's no acceleration, so we can just almost cross this out. Solve for that. You get 22.56 meters. That's your x direction. Perfect. B, we do the exact same kinematic, but in the y direction. We'll just label that y instead of x. Velocity initial is 8 sine 20 or 2.74 meters per second. 3 seconds plus half 9.8 meters per second squared at 3 seconds squared. And then your y equals, solve all that down, 52.32 meters. Okay, so pretty simple. Okay, part C. So you're going to find after it falls 10 meters. So we're going to actually use the same kinematic, but we're solving for time this time. It falls 10 meters. Its initial falling was 2.74 meters per second. T plus half 9.8 meters per second squared. T squared. So, and then from this you create a quadratic, which is 4.9 meters per second squared. T squared plus 2.74 meters per second. T minus 10 meters equals 0. Then you have to solve for t using quadratic. Quadratic is t equals negative 2.74 plus or minus the square root b squared 2.74 squared minus 4a is 4.9, c is negative 10, all over 2 times a is 4.9. You end up with 2 equations, but one of them is negative, so you can cancel that one out. So you get 1.18 seconds. T t equals 1.18 seconds, and that is it.